So I have to say, I'm pretty intrigued about turning this Goodman mechanism with a few adaptations into a 3D printer. Incidentally, I'm doing my best to go for my Anthony Hopkins Hannibal Lecter lookalike competition. Seriously, I've just washed my hair. So we're going to use this basic mechanism, and of course I need some bits to do that. Now, I have this thing. It's an Easy 3D mini printer. I saw quite a few reviews about this, so I bought one, giving it a go, and honestly, it's okay, but it's sat in the corner, and I thought, well, there's a whole source of donor parts. Now, I only paid £90 for this. It's what it was on Amazon. I've seen it on Temu since for about £50, but it's a basic machine. It's not, brilliant, but the parts will do for me for the little project I've got in mind, and I aim it to fit on this bed. So we've got a fair bit of resizing and redesign of this to do. Then we have to disassemble this for its parts and give it a go, trying to make that plate that we were talking about to turn the Goodman mechanism into an alternative for drive belts. Now, it's always interesting to take things apart because it shows you what is actually being used rather than what you think might be being used, because there's always a tendency to overthink things. Now, of course, this machine is a budget machine, and so, costs have been cut, and so some of the decisions made were probably, well, they're not particularly high-end, but then if you want high-end, you're gonna pay money. If you're doing a sort of basic machine at a very low budget, then some of the ideas in here are well worth embracing. If you want to upgrade that, by all means, but you're going to be paying money. Now, this is the main slide from the print bed, and all it is a couple of steel rods with some brass bushings on it. Bit of oil is going to work well. To attach it, it just uses this plastic clamp. The clamp clamps onto the bushing, and that's good enough to actually get a pretty decent slide. The print bed itself, well, it's just a block of 5mm acrylic with some springs and screws. Again, doesn't look particularly challenging, but it does give you an idea about how to think about something dependent on the budget that you want to spend. And all of these things, of course, can be upgraded. If we have a look at the main print armature, which is right here, again, I've pulled off the wiring yoke to expose the basics of it. There's stepper motor there, yes, is it? No, that's a drive motor. My apologies. That's for driving the extruder. There's a stepper motor in there. And then it's got the belts attached to the plastic. On the other side, we've got a limit switch, and you can just make out the drive gears in here. So again, really simple. And the bushings here are exactly what we looked at when we looked at the Z bed. They're just those brass bushings sliding along these silver steel rods. Right, these are the bits that I'm actually interested in, and I could have probably bought these for, I don't know, £10 or so, but I had that thing lying around, so why not? We've got a bunch of guide rods, we've got a bunch of bushings, we've got two identical stepper motors there, and 12-volt stepper motors, and then we've got this thing, which is the actual head itself. I've also kept these are the cooling fans, and the reason I've kept them in the case is it gives me information on the position of the cooling fans, which I haven't taken yet, but I've got a couple of cooling fans as well. And they're going to be core to what I actually want to do. And as I say, it's a surprisingly small number of parts that would be surprisingly cheap to buy, I think. The first thing I think is to construct a gantry system. I'm thinking something like this. Now that might look very different, but surprisingly enough, it isn't. The Goodman mechanism, the hypercycloid drive, and the Tusi couple are all basically the same thing. In fact, they're just different arrangements of the Tusi couple. So when you arrange them in slightly different ways, they can look dramatically different and can be good for a particular job, but the principle is identical. So that thing's quite large. It's 250 by 250, and I've decided to print it on the Elegoo Centauri carbon. Now, I'm printing it on the carbon because the whole thing is print in place, and of course the bed on the carbon is 256 by 256, and I need 250 by 250, unfortunately. The carbon has like a restricted print area in the bottom right corner, which is used for the cutter, the filament cutter, and you can correct that or use that bit of the bed if you do two things. One is remove the filament cutter block, And that's in the right hand side, and you use an Allen key and take that block off. And the other thing you need to do is to reset the print bed area, and you find that in the print settings, and you just reset the bed area to 0 by 0. Bingo, you can now print in the whole bed area. It does have an effect on the filament unload. When you unload the filament cutter doesn't work, and so you have to manually cut it with a little lever on the side of the actual print head. And when it's printed out, that's what it looks like. Now, I've removed the holes in it because I made a design decision about this, because what I'm aiming for is a friction drive. Friction drives have a lot to commend them, especially in a low torque application like this. Now, I've used gears in this version because we want to make sure everything's working. When you're making something new, take one step at a time. If you take 2 steps or more, then you're not going to know what it is that's actually not working. Now we know gears work, we've already made a Goodman device. So I've done it with gears here to make sure that it works. Then what I'll do is change it for the friction drive to make sure that the friction drive then works. So this is a geared version. Let's have a look inside. So if we take that ring off, we get the central plate. Take the central plate off and you can see the gears. This sled is driven by this tiny gear here to make the sled rotate in the same way that the Goodman drive did. This takes place of the arm. If we take that off, there we go. It's geared underneath with our idle gear and our drive gear, and these are in the ratio of 2 to 1. So that's 40 teeth and that's 20 teeth. When we add that back on and turn this gear here, there we go, there, it'll turn the sled and this will move backwards and forwards. So there it is, it's got this slide guides on that I stole from the 3D printer, and of course in here it's got the bushings that are on that actual bed, and they've just been press fitted in. Now of course what happens if I turn this little handle is it does exactly what it says it will do, and that is slide backwards and forwards in a straight line. Now of course that's where I'm going to put my stepper motor. We also need to be able to drive this around, which we'll do in a bit later, and that is the geared version because I want to make sure everything fits and everything works before I do my friction drive version. Now it looks very different, but then it's going to when you actually implement it. Remember, this is just for the theory. This is much more for the practical application, and so that arm, which was never up to very much, has been taken care of by giving it guides. This is the same thing as that arm there. The backlash we've talked about in a previous video, it won't be an issue for me because I'm going to use a friction drive. But I thought I would share that with you because the moral of this story, if there is a moral of this story, is of course that where you start is often not where you end up. Anyway, I hope you enjoyed the video. Thank you very much for watching, and please do remember to like and subscribe.